The scene is now ready, and you'll start by animating the trumpet. Actually, to make the scene easier to read, disable the viewport background. Simply press Alt-B in the camera view and disable the display background option. The background would still be processed at render time. Apply a stretch modifier and set its deformation axis to X. That's the deformation effect you want to animate. Instead of keyframing the stretch values, you will use an audio file to control the amount of stretch. Right-click the trumpet and go to the curve editor. Expand Modified Object, Stretch, and highlight the stretch track representing the stretch value. Right-click it and choose Assign Controller. From the dialog that appears, select Audio Float and click OK. Another dialog appears where you can define which audio file will be used to control the animation. Browse and select the trumpet.wav audio file you downloaded for this tutorial. Remember, this is the isolated trumpet sound as opposed to the final mix set to play with the animation playback. Without dismissing the displayed windows, play back the animation to see the effect. The stretch modifier deforms the trumpet based on the audio file, but the effect needs adjustments. First, increase the maximum value to 2 so that the stretch effect is a bit more visible. Also, you might have noticed that the effect is a bit jittery. You can help by adjusting the oversampling value. Without getting too technical about it, increasing the oversampling value softens the curve of the wave file. Try it at a maximum value of 1000 to see the effect. Notice how it jitters a lot less. You may need to bring it down a bit to about 500, but feel free to experiment with other values. Close the dialog and the curve editor when done. Repeat the procedure on the high conga object. First, apply a stretch modifier to the form in the z-axis. In this case, you'll be needing a negative stretch value. Assign an audio float controller as you did earlier. Only this time, choose the high conga wave file to control the stretch value. Set the maximum value to -1 and test the animation. Again, the effect seems too jittery, but in this case for another reason. Take a look at the high conga wave file and notice that other than the spikes representing the drum sounds, there seems to be some continuous noise based on some muffled snares and other various instruments as well. These were left in the audio file on purpose to show you how you can fix a similar problem. In this case, you only want to account for the sharp spikes in the audio file and none of the low volume back noise. For that, you can adjust the threshold value so that the audio file only affects the stretch modifier once it hits a certain volume. Unfortunately, there is no visual way to achieve this, so you need a bit of trial and error numbers. At 0.1, you are actually removing too much audio information. A value of about 0.03 or 0.04 should work well in this case. Also, keep in mind that real-time playback in the viewport may not work too well depending on your system speed. You may need a preview render for further adjustments. Repeat the procedure on the second drum using the low conga wave audio file. Finally, you'll work on the double bass, and you'll do something a bit different there. Instead of using stretch, you'll use the bend modifier to sway the bass back and forth. Add a bend modifier based on the default Z-axis deformation. Test the effect. It would be nice to limit the effect so that only the main body is bending. Test the bend angle again and consider the following. You need to bend the instrument back and forth in both positive and negative angle values. You cannot do that using a single audio controller, so you'll need to get creative a little bit later. First things first, apply an audio controller to the bend angle value like you did with stretch earlier. Choose the bass wave file as a control file and set its maximum range to 60. That's as far as you want the bend angle value to go. Test it out and you'll notice two things. It is jittery and it is only bending in one direction. To decrease jitter, increase the oversampling all the way to 1000. You can already see the effect in the curve editor. To sway the bass back and forth, you can try and set a negative value for the range, but that doesn't work too well. This will make the initial pose at frame 0 one where the bass is already bent. Leave the minimum range at 0 and close the audio controller dialog box, but keep the curve editor open. With the angle track still selected, choose Curves, Apply Multiplier Curve. Expand the angle track and select the multiplier curve track. At this point, it's a constant line representing value equals 1. If you were to select the two control points that make this curve and set their values to -1, the bend angle values would be reversed. Now the bass is bending the opposite way. To make the bass bend back and forth, you need to adjust the multiplier curve to alternate between -1 and +1 values. Assign a new controller to the multiplier curve, this time choosing Waveform Float. Set the period to 100 to slow it down, and the amplitude to 1 so that the curves range from -1 to +1. Remember that the real-time performance in the viewport doesn't always match the final render. This means you may experience some synchronization problems as you play back the animation. Your scene is now animated and ready for render, but if you would like to experiment with one last fun factor, you can use a device like your mouse or keyboard as a motion capture device to control the behavior of an object. In the next and final movie, you'll use the mouse to control the rotation of the trumpet in real time as the music plays.